Welcome, everyone, and thank you for joining today's workshop. We're excited to have you here. Today's session will be led by our Director of International Sales, Dr. Melissa Cow.
Hello, I'm sharing my screen. Welcome, everyone. Thank you for joining us today. I hope you can see my screen now. In this session, we will walk through a standardized field-proven solution for airport-wide passenger flow monitoring from curbside to gate, including the discretionary area like retail and lounges. What you will see today is not a pitch, but a reference architecture, a comprehensive starting point that airports can adapt module by module to fit their own operational and digital transformation roadmaps. Our goal is to share the best practices we have implemented in large-scale real-world deployments, and also to introduce the technical capabilities that underpin them, including our video AI analytics, the Bluetooth, and 3D stereo vision. So this isn't just about counting or the sensors, it's about enabling a reliable data foundation to support predictive operations, queue optimization, retail performance, and service level compliance in an airport environment. We'll keep it technical and transparent and professional throughout. This webinar is designed to help you evaluate and shape your own airport analytics strategy. So whether you choose to engage with us or not, yeah, let's begin. So the scope this is part of a webinar series, and in this webinar series, we have structured a full journey to help airport operators to adopt a scalable, future-proof passenger analytics framework. In our last session, we focused on the RFI stage. On here, where help airport understand the range of the solutions that are available, the best practices adopted by the leading hubs, and how to define a realistic and tailored scope of requirements. That stage is about asking the right questions, gathering the input from different vendors, consultants, and within your own internal teams to shape a vision that is both ambitious and while achievable. Now, today's session, we're going to focus on the responses to RFP, and specifically what a standardized, modular, and industry-proven solution should look like. We will share the FootfallCam's end-to-end system blueprint, covering every zone from curb to gate, with a practical delivery path that allow phased deployment and also the measurable outcomes. This reference architecture is designed to be adapted. So whether you're issuing a RFP now, or you're reviewing the proposals or aligning your internal stakeholders on a unified strategy. And crucially, the data foundation is built on open architecture, allowing the integration with your other system to enable predictive and prescriptive analytics. So what's the outcome? Is then a more optimized passenger journey, where inflow is balanced with the processing capacity, and these discretionary areas are fully understood, and service level performance can be continuously improved through real-time insight. In the future workshop, we will continue this progression, covering the RFQ stage, where we break down the total cost of ownership, the CAPEX and OPEX models, the SLAs, the validation, and the support planning. And then finally, we will deep dive into the passenger journey optimization. So we will show how to simulate what-if scenarios, and how we train the operational AI models and embed SOPs across teams using a scalable analytics platform. And ultimately, and as many of our airport customers told us, they are to reduce the queuing time at the mandatory security processing area, in order to increase the dwell time at the retail commercial area. So today is about the how, a reference solution you can take forward and adapt and then benchmark as part of your own digital transformation roadmap. So to understand and optimize the passenger experience, we first need to define the full scope of the airport journey, from curb to gate, for the boarding gate. Now, this journey is remarkably consistent across airports worldwide. It begins at the car park or the drop-off points, proceeds to enter the terminal building, the check-in counter, security, immigration, and to the boarding gates. And on the arrival side, it then starts from from the flight to the gate and the arrival, immigration, baggage claim, customs, and ends up at the transportation hubs like the taxi stands or the pickup zones. Now, each of these stages contributes to the overall passenger experience, and each stage has its own cues, service points, constraints, and operational challenges. Now, one of the goals, so our goal is to digitize and measure these stages in real time, not just to report, but to enable a real-time operational decisions. That means tracking the inflow, the outflow rates, the waiting time, the service desk utilization, staffing level. So it also means identifying when and where delays or congestion occur and triggering the corrective actions before an SLA breaches happen. So with enough visibility, the airport managers can then ensure that queues don't build up excessively, that staffing is dynamically adjusted based on demand, so whether or not you're opening more or you're closing some of the lanes, and that service lanes are open or closed at the right time, as I said there. So this protects both the operational performance and the commercial outcomes, because if they spend less time here, that means they will then go to your retail section. So by ensuring ensuring the passengers do have time to visit the retail, to dine and or relax before boarding the flight. So achieving this requires data fusion. So we combine real-time video analytics, boarding pass scans at some specific points, Bluetooth tracking, your AODB flight schedules, staffing rosters. So together, these inputs create a digital twin of the passenger journey, enabling a data-driven optimization at every step, from terminal entry to the aircraft boarding and back again. So why is this such an urgent discussion now? Now, most airport operators already understand the value of passenger flow monitoring. It is not a new idea, but what has changed is the urgency. Now, according to IATA, global passenger traffic is expected to double by 2040. But airport infrastructure in most countries isn't expanding at the same pace. So new terminals will take years to build, and that means existing facilities must do more with less. So more passengers per hour with the same space and the same resources. The only way to make this work is to optimize operations through data and to use real-time measurements and machine learning to manage the capacity smartly, to reduce congestion and protect the passenger experience during the peak hours. We're exciting now. What's exciting now is that we're no longer just reporting delays. We are moving towards prescriptive actions. The system learns from past traffic patterns, uses the flight schedules from the AODB, and so that you can then predict where the pressure will build up, and you triggers operational recommendations to preempt those issues. And even better, the system continuously learns. It compares predictions with reality, and then it refines the model and improves its accuracy over time. This is a scientific approach to operational excellence, and it scales. But at the same time, we recognize why adoption hasn't been widespread in the past, mainly because it was costly, complex, and fragmented. They're often siloed by zone, like the security here and the immigration there, but that's changing. With lower total cost of ownership, modern system can now be deployed across the entire passenger journey, not just at a few checkpoints. And when you combine with AODB data and workforce systems. They can drive real system-wide transformation. So, however, but for this to succeed, it must be financially sensible, technically interoperable, and respectful of the data ownership and privacy. So operators are cautious about vendor login, data silos, and system that can't integrate. So this solution must be open, hybrid friendly, and designed to support both on-prem infrastructure and cloud AI. So ultimately, most airports agree the time to act is now, but it must be done step by step, backed by data and proven to deliver the measurable results, both operationally and financially. So now, why are more airports moving in this direction and what's guiding them? Passenger flow, as we mentioned just now, the passenger flow monitoring isn't just a technology trend. It is now part of a global standards movement led by those key aviation authorities. This is a highly specialized domain, so most countries only have a handful of international airports, and everyone in the field tends to follow a shared playbook. Across the board, we see three clear pillars emerging from the global guidance. First is measurements. So establishing a consistent and standardized way to measure how passengers flow through each stage of the journey. This includes the inflow, queuing, service rate, dwell time, and most importantly, how that aligns with service level agreements. Second is open data. So all of the major frameworks now emphasize breaking down the data silos, whether it's the ACI or IATA. They call for open architecture and standardized data formats to ensure that flow data can be integrated with other core systems like the AODB, ACDM, the flight dispatching and staffing tools. The third thing they're looking at is the prescriptive analytics. So using the data collected to move beyond reporting. So it's not just about reporting, analyzing the data. They're moving into actionable insights, which is then the one that really brings value. What should I do when you have data, right? So this means applying the AI and simulation models to do predictive planning. So the real-time scenario analysis and operational decision-making at scale. That includes building dashboards, learning from historical trends, and standardizing how we visualize and measure improvements. So now let's quickly look at some of those specific initiatives. So you can click on these guidelines. This is from the ACI guidelines, and this is from IATA. So they're talking about. So you can quickly look through this one. For example, here they're looking about measuring demand and capacity analysis, how they should analyze the capacity and demand, whether or not they actually are they regularly conducted, and whether or not they align, and what do the airport do if it doesn't align, all this. But briefly into that, the ACI Smart Airport Initiative promotes the queue and flow monitoring as the core tools to manage capacity and to benchmark the KPIs and guide for expansions. So it strongly encourages the openness and interoperability in between all these different management software. IATA next, they positions the crowd flow analytics as a pillar of the digital airport, pushing for machine learning powered prediction and system-wide awareness, and in real time as well, from gate planning to workforce management. And increasingly, the CAA are incorporating flow monitoring into audit frameworks. Especially around their SLA adherence, crowd safety, operational resilience, with special funding now being directed to the Tier 2 and Tier 3 airports for digital upgrades. So in short, the direction is clear. Global aviation bodies are setting the foundation for a data-driven, standards-compliant transformation. And what we're offering aligns tightly with that vision, helping airports meet today's challenges with a scalable and future-proof approach. So why FootfallCam? Why are more airports choosing us for their passenger flow initiative? The first, FootfallCam is a globally established player in the field of passenger flow management. We're not new to this space. Our systems are already deployed at scale across different transport hubs, shopping malls, and very large public venues worldwide. In fact, we are installed in the largest public venue in the world. What sets us apart is our ability to design a tailor-fit solution for airport environments, not just a one-size-fits-all product. We align closely with the operational realities and long-term goals of airport operators. So, can have a look at this on there. So that's how we are measuring, everyone who is now in the queue. We're tracking them. Now, let me break it down into the three key reasons why FootfallCam is we have a comprehensive coverage with fusion technology. So we are the only solution on the market diffuses 3D stereo vision, AI video analytics, and Bluetooth BLE tracking into one seamless platform. The fusion enables us to monitor the entire passenger journey from curb to gate, from car park to arrival hall, or from disembarking from the flight all the way to the arrival hall to the taxi stand, with the right sensor at the right spot. Our architecture supports the, for example, here you see the wide angle fisheye lenses for large spaces, a top-down stereo vision for high accuracy in-out counting. When you have a lot of crowd on there, we are embedded with our 3D stereo vision. We also have the Bluetooth BLE tracking for a passive anonymous journey level re-identification. And we can also integrate with existing CCTV systems where applicable. So with all of this done without overloading the airport's network. So these are all edge processing and multicast streaming as default. Now, the second reason is because we deliver an unmatched cost efficiency. So typically 10 to 20 times cost advantage over the traditional solutions and our competitor. And that is not an exaggeration. Our coverage per sensors are wider, and our Bluetooth BLE tags are license-free, and we reduce infrastructure and deployment costs. So not only just on the hardware costs, we'll cover this a bit more, not only just on the hardware costs, but also on the cabling and all those infrastructure deployment costs. We reduce that significantly. So with fewer devices, flexible mounting options, and software-driven analytics, we make the curb-to-gate tracking financially viable, even for large airports or the tier 2 and 3 locations. Now, the third point is because our accuracy isn't just a claim, it is validated. Our system automatically benchmarks the output of each different technology, the AI, the 3D, the BLE, against each other, identifying anomalies in real time. And this internal triangulation allows us to self-correct and ensures that each zone and each flow point is measured with confidence. So we also support ongoing calibration, alerting, validation frameworks, making our system future-proof and auditable and reliable. So in short, FootfallCam thus offers the best-in-class technology, the broadest coverage, and the lowest total cost of ownership, all backed by a proven track record and a rapidly growing presence in airport digital transformation projects. This is why we're speaking to major operators across the globe, and we strongly believe FootfallCam should be part of every serious digital transformation proposal in this space. Now, let's take a step back and look at what exactly our system can do. These are the core building blocks, the fundamental use cases that our system fully supports, and that together form the anatomy of a modern airport analytics platform. Each of these functions is supported out of the box. So using data captured by our multimodal sensing architecture, combining the AI video, the 3D stereo vision, and the Bluetooth, and they all map to the key operational outcomes across the passenger journey. So let's walk through them briefly. Now, passenger counting, this is a solution, this is the foundation. So real-time high accuracy in-out counting at entrances, like entrances to the terminal building or the lounges or the retail shops, arrival halls, or this. It enables understanding of the footfall patterns, the flow capacity, and for forecasting demand. Queue monitoring, so we support real-time queue length, queue waiting time, and the service throughput analytics at check-in, immigration, security checkpoints. So this helps detect congestion, SLA breaches, and staffing inefficiencies. Now, we also track real-time and historical occupancy of key facilities. For example, like at boarding gates, the lounges, or the rest area, the prayer rooms. So this enabling dynamic capacity planning and passenger comfort. Lane and counter usage monitoring. So we automatically detect lane level activity. So their actual open time, their serving rate. So this can be at immigration, check-in counters, or e-gates. So this helps identify the underutilized assets and optimize the throughput. Now, passenger flow mapping. So we use AI-based flow detection and trajectory analysis, so we can visualize the flow direction as we showed just now on in the live view, and we can detect bottlenecks because of that, and map the movement paths across the corridor, transit area, and those. Journey level tracking. So this one we use a fusion of Bluetooth and AI re-identification techniques. So we reconstruct a anonymous curb to gate journey. So including the time spent in the discretionary and the mandatory zone. So giving deep insight into behavior and service impact. So for example, if you have if your queue is very long and take a long time in the mandatory security area, then it reduces time they can spend at the retail area, so forth. So the journey level tracking is very important for this level, and that goes to the retail and commercial analytics, because for the non-aeronautical revenue, for here we support measuring the dwell time, footfall, sales conversion, the path to purchase behavior, all this tracking in the retail and F&B areas. So helping the operators and tenants also to make informed decision. VIP lounge management. So for premium passenger segments, we track the volume, the dwell time, the usage pattern, and the capacity planning in the lounges. So enabling a better experience design and capacity utilization. Then you come to the arrival side, your baggage hall. You can monitor the arrival flows, time at the baggage belt, and onward movements to customs and exit. So allowing the visibility over the baggage handling performance and the customer experience post-arrival. Now, another optional one is if you want to have the demographic insights. So all of our AI vision analytics, we can have a fully GDPR or previously any country's previously law compliant manner. We can provide demographic breakdowns like age and gender. And this is for anonymized trend analysis, so supporting experience personalization and marketing decisions. So each of these represents a standalone use case, but more importantly, they serve as the functional building blocks for modeling the end-to-end airport journey. So with the right architecture, these data points can be combined to form prescriptive and actionable insights, not just for reporting, but for real-time operational decision-making. So in the next slide, we'll show how these functions are stitched together in a complete passenger journey map and how airports can use it to monitor, predict, and optimize the performance across each touch point. Now we're going to just look at what we could do at each different touch points. So one of the most critical zone in an airport is a check-in area, where long queues can quickly result in frustration, missed flights, and operational bottlenecks. Our system provides the dynamic queue monitoring capabilities and purpose-built for the check-in environment. So here's how it works. So we monitor the queue length at all time, 24/7, and using AI vision, we'll continuously measure how many passengers are currently queuing, how fast the queue is moving, and how is evolving over time. And this is done without wearing devices or manual input. And we also provide real-time alerts for staffing optimization. So when queues begin to exceed the predefined threshold, you can set that threshold. And then when it exceeded that, the system can automatically trigger the alerts to the terminal supervisor. And so prompting them to, for example, here, prompting them to open more queues because you have more people joining the queue. So, or open more counters because you have more people joining the queues. And so this allow them to maintain the service level during peak traffic and without overstaffing during the off-peak hours. And we have automatic counter opening closure detection. So we don't have to rely on people manually inputting and telling us which counter is open. Through the camera analytics and AI, we can detect which counters are open. For example, detecting the dynamic signage, like the screen status, whether the counter lighting's inside, and the passenger activity in front of those counter were there. So like obviously there's no one in front of there, that counter's not open. So we are auto detection whether they're open and closed. So literally the airport staffing, the operators there, they do not need to have any sorts of menu input. So we remove all the need for menu tracking or staff reporting. So it's automatic. So the KPI measured for the check-in counters will be queue length. So how many people are in line at the time, obviously for the main check-in counter to the self check-in kiosk on there. So the queue length, the average waiting time. So this is real time as well as historical wait durations. The passenger throughput per desk, the service rate per counter, and the overall check-in area throughput, the whole area, the aggregated performance for the zone. You can obviously have different zone like domestic, international, or your check-in zone A, B, C, D, and things kind of thing. So you can aggregate them onto different things. And we also do a prediction, a calculated value based on the current demand and the SLA thresholds. So we can then tell the operator what is the number required counters that needs to be open now. So they can then have a actionable alerts for them and say, okay, open 2 more counters, for example, if you've seen there. Yeah. And for security checkpoint, now moving on to this is one of the highest pressure zone in the airport journey because where delays can cascade into missed flights and disrupted schedules. So our system focuses on 2 key aspects here, which is the occupancy monitoring and the lane level service throughput monitoring. So first we track the occupancy at the checkpoint entrances using accurate in-out counting. This gives a real-time visibility into how many passengers are queuing and entering into this area at any given moment. Then second, we measure the service throughput. And that is how efficiently each lane is processing passengers. So this includes both the queue built up and how fast it clears. And with these insights, the airport operations can dynamically allocate resources. So then you would say, tell them, open 1 more lane. And then when they're open, obviously people move into it and the queue size reduce and queue time will reduce as well. So this is how we dynamically allocate resources for that. So the result of it, of course, then is fewer bottlenecks, shorter wait time, and improve the checkpoint efficiency. So these are the KPI measured. So we measure the queue length per security lane, average wait time per lane, the passenger throughput per lane, and also the occupancy trend. This is both from the incoming and outgoing flow. So the occupancy, the full queue over here in that area. So these indicators help to ensure that the service level targets are met while also providing the data for post-event review, planning, and audit purposes. Now, these are from the departure side. So let's talk about the baggage claim, the final impression of an airport experience, and one that is often overlooked. So our system provides a real-time crowd detection around each baggage carousel, and it identifies where passengers are gathering and automatically flags any sign of congestion. So when the crowds built up is detected, the system triggers automated alerts to operators so they can quickly investigate potential delays in the baggage delivery, address the root cause, and reduce the passenger frustration. So we also integrate with the baggage handling system to track the first bag and last bag delivery times. So this enables the SLA compliance monitoring and helps evaluate the ground handler performance. So the KPI we measured is the average waiting time per passenger, the predicted waiting time based on the current flow. So this would be the live real time now, and the real time occupancy at each of the baggage carousel. So with this setup, the operators can gain visibility and control over an area that directly affects the passenger satisfaction and terminal efficiency, so ensuring a smoother conclusion to the passenger journey. Now let's move on to the retail side, the retail zone, which is a high value area for the airport non-aeronautical revenue. So using a combination of Bluetooth tracking and video analytics, so we can monitor which passenger visit which shops, how long they stay inside the shop and or in the retail area, and even identify the gaps in engagement. So whether the passengers have walked past outside, but they didn't enter. So from an operator perspective, this allows for flight level behavior analysis. So understanding what passengers on flight A did versus those that goes on a flight B. And this supports the attendant rate justification and lease optimization decision for your retailers. So our system also uses flight schedules. So we integrate with AODB to predict also upcoming footfall and provide retailers with an early forecast of expected traffic. For example, you have a flight cancellation or a flight delay, or changes in any of the flight. So for example, for transit passenger, when you have a flight delay, it just means that they have more time in the departure hall that would then allow them to go to a restaurant to have a meal. So you might have a surge of people going to the restaurant. So you need to then alert your F&B to tell them potentially we're going to have more people coming in to dine. So this enabled them to plan staffing and stock and all those things. So the key KPI measured footfall per shop, the visit duration, dwell time, outside traffic, number of people who passed but did not enter, real-time occupancy, the predicted footfall from upcoming flights, sales conversion metrics, the revenue per visitor. So with this, we give airport operators and their tenants a clear view of passenger engagement so they can optimize layout, promotions, tenant mix for maximum yield. Lounges are a critical part of the passenger experience, and whether it's the general seating area or the dining lounges or the VIP zones or those airline premium lounges. So our system provides a real-time visibility into who is visiting, who and when they come and how long they stay. So, and using the Bluetooth tracking as well and the entrance counter, we measure the footfall, dwell time accurately. This helps airport operators ensure the lounge is comfortably occupied without overcrowding at the peak hour during the busy periods. We also forecast the upcoming peak hours based on, again, flight departure schedule, allowing you to predict the lounge traffic and allocate the staff more efficiently. So this applies not, as we say, not only the standard lounges, but also the premium lounges where usage data can justify the service level and support operating and planning. So the KPI measured would be the total lounge footfall, the predicted footfall based from the upcoming flights, real-time occupancy levels, and visit duration per passenger. So with this data, again, airport managers can ensure premium experience, maintaining the service SLA, and plan the resources with data-backed foresight. Car park. So we know the passenger journey doesn't begin at the terminal. It actually starts in the car park or it ends in the car park. So with FootfallCam, we can extend that visibility all the way to the parking facility, and using your existing CCTV cameras to monitor the individual bay occupancy in real time. So we count the cars. So this data is integrated with also your digital signage system, so helping the drivers navigate to find an available parking space. So whether that's on the upper floor or the basement. And so the goal is simple, is to reduce the time spent searching for a parking space and to minimize congestion inside the car park. This also supports dynamic space planning, as we mentioned that by analyzing the historical parking patterns, airport can optimize parking zones for peak travel times and also according to flight schedule. So ultimately, this isn't just about space utilization, it's also part of delivering a seamless and stress-free arrival experience or departure experience for your passengers. So the KPI measured are like total number of vehicles in the car park, number of occupied bay, number of available bay. So with this insight, the airport operator can proactively manage traffic. And of course, with that, then you reduce frustration and you ensure the journey starts or ends on a positive note. So another location, it would be like the taxi and the ride-hailing lane. So for this are often the first and last physical touch point for many passengers, either at the drop-off or the ends with getting a ride home. And is also a frequent source of complaints when queues are long or the coordination is poor. And this area is typically semi-outdoor or even completely outdoor with a large coverage zone that you need, and they are not well suited for the traditional sensor which needs to be on the ceiling. So, and that's where our FootfallCam video analytics come in, because we can use your existing CCTV infrastructure that are already in place, and we can cost effectively provide a real-time visibility over the vehicle flow as well as the passenger demand. So how many vehicles are here? How many people are queuing over here? And what is the congestion looking like? So all this, we track the inbound, outbound passenger flow, forecast the demand, monitor, like as I mentioned, the vehicle queue length, and helping the ground staff to proactively dispatch the taxi and the ride-hailing cars. So during congestion, the system can automatically trigger an alert to prompt the traffic officers for intervention, like opening additional holding lanes or temporarily increasing dispatch frequency. All this. KPI measures are the predicted footfall, the predicted passenger that will come based on terminal inflow from the terminal building, and the queue length of waiting passengers, those that are there, and also the number of vehicles queuing up. So this would be what we're going to measure there. So then with this, the airport can ensure smoother ground traffic flow and a far more predictable and pleasant departure and arrival experience. Now, let's talk about one of the most important enablers of the entire Curb to Gate initiative, which is our Pro 2, FootfallCam Pro 2, and its sister device, Pro 1. Now, this Pro 2 is our flagship stereo vision AI sensor with 3 times wider coverage, very powerful chipset inside, including with an NPU, 8 TOPS NPU with a GPU built in and a very powerful processor. Now, but what makes it truly revolutionary is how it works in tandem with our Pro 1. So each Pro 2 can support up to 7 Pro 1 over a PoE. And this lets the Pro 2 act as a central AI hub. So it becomes a central AI hub and handling all the processing locally on edge on the Pro 2. And so instead of deploying 7 intelligent devices, you're essentially deploying just the one with 7 inexpensive extensions. So this lowers the hardware cost dramatically. And so compared to alternative solutions in the market, this configuration is not just marginally better, it is 10 times cheaper in the device cost alone. But the savings actually go far beyond that, because we now need less cabling. We now need fewer smart devices with the wider coverage, and also means less cabling, fewer switch ports, lower infrastructure burden. So which together will bring the total cost of ownership down by up to 15 to 25 times. So now, why does that matter so much for an airport? Now, where airports have many challenging environment, and probably stop that. You have high ceilings in the departure hall, and then other area like the border control zone could be a very low ceiling zone. So you can't have one sensor fit all. And also with the low, and then some places is very wide coverage area. So competing solutions would require probably 100 to 300 sensors to cover a single zone, a large zone. But with our solution, you can achieve the same outcome with a fraction of the hardware, because with our 3 times wider coverage and the 25 times lower total cost of ownership. So that's the key to making a large-scale analytics feasible and sustainable. It is not just about better technology that is important, but it's also about better economics for that. And here's another major differentiator. All the Pro 1 and the Pro 2, we all equipped with the BLE, the Bluetooth Low Energy. That means every device is not only a people counter, but also a Bluetooth scanner. So enabling the journey level tracking across the airport. So we can now determine where the passenger goes, which shop they visit, how long they stay there, and how these behaviors vary per flight or per airline. So all of these are also processed at edge. So using the latest AI chipsets inside the Pro 2, giving you a real-time, scalable, and cost-effective intelligence from the curb to the gate. So again, this is more than just a device. It is a cornerstone of our airport-wide deployment strategy. It's built for scale, for performance, and for sustainability. Now, the next one is the extend. This is in many modern airports, especially around the check-in halls, the lobbies, the departure area, we often face the challenge of very high ceiling. So sometimes reaching up to 25 meter. So this is where the traditional sensor simply can't cope at those heights. So, but our 3D extend is specifically engineered to solve that problem. And with the latest hardware and the AI upgrades for our extend, this sensor now features a 2000 by 2000 pixel resolution. So you can process video at 15 frames per second and is capable of tracking up to 2000 people simultaneously in one single wide area zone, in one viewing angle. So that means that we are now able to cover 3 times the area of any competing system without sacrificing the accuracy. And in fact, thanks to its stereo vision architecture and the AI optimization, we are delivering precise people tracking. So we actually see the tracking of those paths where people are going, even at the extreme ceiling heights and across large open spaces. So again, the savings are significant. Fewer units are needed, so reducing the device costs, less cabling and installation work. So it also cuts infrastructure expenses and higher processing power at edge. So allowing everything to run in real time without overloading your airport network. So altogether, we're looking at a tenfold reduction in total cost of ownership just by deploying a smarter, more capable devices. And this is made possible by our investment in the next generation AI chips, like I mentioned there. So we can leverage on the exponential growth in the processing capabilities. The next device we have is the Centroid 48. This is a AI video analytics at scale. This slide we introduced, this is very powerful, a high density AI video analytics box that can handle up to 48 of your IP camera, your CCTV IP camera streams simultaneously. And it's extremely cost-effective and space-efficient solution. Is perfect for the large-scale airport deployment. So with just the one box, you can cover very wide area and include those corridors, your lounges, your washrooms, and concourses. So all with real-time occupancy counting, zone analytics, heat map, flow analytics, visitor flow tracking. So what makes the Centroid 48 especially airport friendly is it support the multicast streaming. That means if your CCTV cameras are already recording to an NVR, which is the most important priority, this box can tap into the same feed, but without duplicating the bandwidth or requiring additional storage. So that's the multicast streaming. Yeah. Then this is where we call the zero impact deployment. And this zero impact deployment design ensures you don't need to upgrade your network infrastructure or worry about overloading your system. And this is something we will dive deeper into a technical webinar technical webinar later. Yeah. So now it's important to clarify, some people confuse the Pro 2 sensor, which I mentioned earlier, and the Centroid 48, but they serve different use case. So the Pro 2 includes the stereo vision and Bluetooth, and is ideal for accurate people counting at entrances, smaller enclosed area, or when you want to count the journey across a long journey path. The Centroid 48, on the other hand, is for analyzing existing CCTV video. So especially in a large or semi-covered or completely outdoor area, and is ideal where budget efficiency and maximum coverage are key. And with the built-in AI-powered age and gender recognition, it also brings the retail grade insights into the airport environment. So at your shops, your lounges and food court, where you already have a CCTV camera, then you can have your continuous video coverage there for all these AI analytics. So to summarize, the Centroid 48 enables airport-wide scalable analytics at a fraction of the cost, because you already have the CCTV. You don't need any more, and with no extra burden on your existing infrastructure. So making it a smart future-ready solution. Now, in the next slide, we're going to walk through what exactly we measure at a typical checkpoint or the service desk queuing area. So such as the security screening or the passport control zone. This is less about dynamics, is less about the flow pattern or behavior. It's more about the anatomy of the data, what metrics are actually captured and how. So from the device level, our system essentially captures two core types of data. First is using the zone-based, so this is a whole zone-based video analytics. So we measure the event-driven counts, how many people entering or exiting the defined area. Or the individual lane. So this gives us a real-time count of inflow and outflow. Second, then is through a stitch multiple cameras. So here you have lots of cameras and the views stitched together. So this is a camera top-down view, and we stitch them together so that we can continuously monitor how people are physically, how they move within a zone at any moment. So giving us an accurate view of queue length, occupancy across all the waiting and divesting zones. So by combining these two types of data, then we can derive a comprehensive set of operational metrics. So specifically, we can now measure queue length at both different checkpoints, waiting time, again, split across both areas, processing throughput, how many passengers are processed per minute, per hour, or per time period, per lane as well. And the inflow outflow rate, which helps to calculate the pressure building up or the dissipation of crowd. the diverse area occupancy, which is critical for understanding the space usage. And lastly, the active and inactive lanes, so to identify underutilized capacity. So for example, here you have loads of queue building up, but you're not fully utilizing your full capacity because those lanes are not open. So this metrics gives airport operators a data-driven view of service performance, helping them to quickly identify bottlenecks, underperformance, or lane imbalance. And all of this is done through a non-intrusive, privacy-compliant video AI and adaptable to both the new and existing infrastructure. So this forms the foundation of our checkpoint SLA monitoring, and it later then feeds into the root cause analysis and real-time intervention workflows, which we'll discuss in the next sections. Now, in these slides, we're going to focus on the departure lounge. And this is critical zone between the security. So after the security, for example, after the security level, then they come into here where they can relax and browse. And in between that and the boarding gate. So where the passenger typically browse, shops, dine, and wait before heading to the gate. So the challenge in this space is how do we cost effectively monitor passenger movement across such a large and dynamic area without requiring full video coverage everywhere? Because this is huge, it's impossible. So the answer lies in the fusion of Bluetooth and visual AI, AI vision. Here is how it works. So in here, the green here are our Pro 2. So each of our Pro 2 sensor or our Pro 1 sensor as well, they are deployed at some of the key store entrances and key corridor points. And these are the circle are the coverage area of each of the device Bluetooth coverage. They have a 30-meter coverage on there. Sorry, we didn't mention that, but there is a 30-meter coverage. So these sensors are deployed at each of the entrances and also key corridor points, and it provides both the AI-based counting for people counting and in-app analytics, and at the same time, they have the Bluetooth and passively listening for Bluetooth signals from the passenger's mobile phone. Now, the BLE alone is not perfect because we probably now know about the MAC address changes and they randomize every 15 minutes. But by combining this with the video ground truth, we can normalize and cross-validate the tracking patterns. And here is a research article. This research article explains how to track even with MAC code, even with the MAC randomization. It just tells you how they scientifically do that and how they come up with a different method to do that. But in a layman's term, in a layman's language, so what it is like, for example, your phone now is showing this MAC address, and in 15 minutes time, it randomized to a different MAC address. But using that method that is is a scientifically proven method. What it does is we build a spatial continuity. So stitching together the movement trails, and this is with up to 80% accuracy. So this lets us answer critical questions like which shop did the passenger visit? Where did they stop to eat? How long did they dwell there? And most importantly, then which gate and which flight did they board? So for this one, with this complete view, you can start profiling the flight level passenger behavior. For example, the passengers on flight A tend to dine, while the passenger for the flight B passengers, they mostly shop. So this becomes an engine for revenue optimization. So allowing you to tailor promotion, reassign units, or plan the staffing based on who's actually using the space and what they do before they fly. And all of this is backed by a real-world deployments and peer review validation, both in major airports and large-scale shopping malls. We have already done a lot of this. And also importantly, no personally identifiable information are collected, so that making sure this is entirely anonymized and privacy compliant. Have that. So the metrics that we're here, we will present a high-level summary of the core metrics that are made available through our system, particularly from the metric data set. So we have a document here which you can reference what kind of metrics that we measure there. But in brief, so we fall broadly into few key categories. So we have the inflow, outflow, queue occupancy, and this is at the most basic level. So we are counting how many number of passengers are arriving, how many are being processed, how many are currently queuing. These are the foundational numbers for understanding demand versus capacity in real time. And then we have the live and historical waiting time, queuing time. This is where the value of metrics really starts to stand out. We're not just estimating delays. We're actually calculating the live waiting time per person based on real-time queue length and the last 20 minutes serving rate. Then we come up with the prediction. And on top of that, we generate also historical waiting time estimates using a first in, first out machine learning model, which can be used for trend analysis, performance benchmarking, and SLA tracking. Now, serving rate and lane utilization, number of active checkpoints, this all helps operational team assess the efficiency of the screening process itself, from how long passengers spend in the diverse area to how many complete the entire process per unit time. So lastly, one of the key differentiator is that this full metric set is available for export, allowing airport operators, business intelligence teams, and analytics vendors to plug directly into their own dashboards, KPI engines, or the predictive models. So while this is a snapshot, it underpins the value of using FootfallCam multi-sensor fusion and real-time analytics to give a clear, accurate, and actionable view of what's really happening at the checkpoint. So now we look at two deployment scenario. One at the security checkpoint. So this is probably one of the most important deployment scenario in the airport for the security checkpoint, where precision matters most. High density, high occlusion, and high stakes. What we have achieved here is a cost-effective, high accuracy deployment by combining the Pro 2 and Pro 1 and the companion Pro 1 sensor. So these are all managed within a single cohesive system. The Pro 2 acts as the main brain, and then you have the Pro 1 extending its coverage across a wide area. And now you could have combined different low ceiling and high ceiling in that zone. So then you can then use the 3D extend as well. So this even across a complex and crowded queuing zone. Unlike LIDAR, which struggles with occlusion, especially with luggage, trolleys, children, and dividers, our top-down AI vision delivers an occlusion-free 99% accuracy. That means every person is reliably tracked through the inflow, the queuing, and the outflow. So even when the scene is packed, and as we mentioned, each of it we can count 2,000 people in the view. And thanks to the visual field advantage of the overhead deployment, we're able to see over the crowd, avoiding blind spots that any side-mounted or a single angle system often suffer from. So this makes it especially useful in long, narrow lanes or multi-lanes configurations, which are very common in border control and immigration zone. It is also cost-effective, as you can see. Pro 2, Pro 1 with your Centroid and Extend all work together seamlessly, forming a unified system architecture. And because of all this, unlike the bulky line of sight LIDAR setup, we can scale at 10 to 15 times cheaper in the total deployment costs. Yeah, so this is more than a counter, it's a ground truth driven tracking system. And we encourage decision maker to benchmark this against the other video analytics or LiDAR system to see the differences for themselves. The second deployment scenario is at the departure lounge. So this is often the most commercially valuable part of the airport, especially obviously for the non-aeronautical revenue. This area includes the retail outlets, duty-free shops, of course, restaurants, lounges. And the goal here is to understand how passengers interact with this environment. Now, it's just not how many, but who does what, when, and where. So in this example layout, each individual retail shop and restaurant, we equipped it with the Pro 2 device, or you can equip it with Pro 2 and Pro 1 device. So these units serve the multiple functions. They count the footfall at the entrances to each of the shop. They count number of people passing by. They also measure the dwell time inside the shop, path tracking, and also with optional Pro 1 unit. If you add additional Pro 1 unit inside the shop, then they can do path tracking, product engagement, heat map, zone level interaction analytics with each of the shop and dining area, or with your CCTV that you already have. You can connect it up, so you can give all this area and analytics on that. But what sets the Pro 2 apart is its built-in BLE. So we have a hybrid of video, AI video, 3D server vision, and BLE system. So what does that is that we have the BLE scanner, the Bluetooth scanner. So we enable the passenger movement tracking across the entire lounge, as we mentioned just now. So even in areas without a full video coverage, the BLE can cover effectively of about 30-meter diameter, as I mentioned, each of them cover that. So for example, with 20 strategically placed Pro 2 units, we can cover up to 100,000 square meters. So this is more than enough for even the largest airport lounges, and at that cost. So this make it very this fusion of video-based ground truth with the Bluetooth trajectory tracking give us a very powerful hybrid approach. So while the Bluetooth signals provide a continuous coverage and passenger movement data throughout the entire premises, the video analytics then give it the context, verifying the ground truth, enhancing the reliability, and enabling the AI re-identification across the touch points. So practically speaking, this means we can track each anonymous passenger across the entire lounge journey. We'll know when someone enters, which stores and restaurants they visit, how long they stay, and finally, which gate they depart from. So all of these are, of course, GDPR compliant and fully anonymized. And it does opens the door to a very powerful insights. And that's why you can then get a shopping behavior of passengers per flight. So are passengers on a certain airline or destination more likely to dine than shop, as we mentioned before? How long do they typically linger in the lounge before boarding? And so this enables the airport operators and retailers to understand per flight shopper profiles and optimize the store placement, promotions, and operational planning accordingly. Of course, we don't need a dense deployment of the Pro 2 or the Centroid units everywhere because that would be costly. And therefore, now that's with the Bluetooth tracking of 30 meters, that's where we are pushing the cost to the minimum on this. And this is just the foundation. In the future webinars, we will demonstrate how all this data ties back into a centralized analytics dashboard, where you can filter insights by time, by gate, by flight number, or even by store. So, and even model the commercial ROI of each passenger flow. Yeah. So now let's go into looking at dashboard. So this is an airport-wide overview dashboard. So in these slides, we are showcasing one of the key reports we provide, which is for the airport operational manager. So these reports comes in two versions. One is sorry, I'm trying to find. in here. So one is the live version for real-time monitoring. So in here, you are looking at from curbside to check-in to border control and so forth. And then you can look at if there is anything that is breaching the SLA with the alert so that your staff can then go and act on it for that. And also a historical version where you can choose a different date, time period. So you can then see a comprehensive view of passenger flow from curb to gate. The value here is identifying where the bottlenecks are forming on there and which stations underperform, whether that's a slowdown at immigration, at which time, whether the slowdown is at the immigration or is at the border, at the security. Apparently security looks very good, or even underused checkpoints. So you can see by the hour which checkpoint needs attention. So going down to like this, looking at the different number of people there. So by allowing the users to drill down into any specific station, it gives a powerful capability to zoom from the macro to the micro, see the big picture, then pinpoint exactly where operational improvements are needed. And that's where this differs from traditional checkpoint monitoring, which only focus on isolated areas like the security or the border control. Those are important, but they only give a partial view of the journey. So with this report, the managers can finally manage the entire passenger journey holistically. So tracking the service level, capacity issues, and process efficiency end to end. So the goal here is not just to monitor, but to enable data-driven optimization at scale. So airport can deliver a better experience, improving the flow and manage resources more effectively. Now, we also want to look at a live operational dashboard, which is like here, as I shown just now. So which is absolutely critical for the day-to-day airport operation. So unlike the report that look back, this dashboard actually gives you real-time visibility. So you can respond instantly when the queues starts to build or the staffing mismatches occur. For example, here, so these are not open. So you have so you only have 3 or 4 of the counters being open here. So this what makes it powerful is that it combines with predictive data as well, such as the expected passenger inflow from the AODB schedules as well, weather-related disruptions. So when you have a thunderstorm, maybe it disrupts passenger traveling to the airport, and so it all delays everybody coming in. And so at your check-in area, you have a big pile on this. Now, this live observation of actual queue length, inflow rate, processing speed, and current wait time. So this allows operators to proactively manage the demand, allocate staff and open or close lane or deploy resources before problem becomes visible to the passengers. And when the queues do form unexpectedly, the system helps diagnose the cause immediately as well. Maybe a lane didn't open as scheduled. So you also have all those alerts in here. So you can then send the alerts to them for that. So so with all this combining, there is also a historical playback mode that allows operator to review the past incident. So you can look back in the playback mode on a certain time, and you can play that on it as well. So you can know what happened, when, and how it was handled. So you can improve the preparedness and reduce any future recurrence. So ultimately, this dashboard helps transform your airport into a real-time responsive operation where every minute counts and issues are addressed before they escalate. Now, so the next one is the actual curb to flight journey, which gives a complete view of the passenger journey experience from the arrival all the way to boarding in here. So it starts with the major milestones. For example, you scan the passport or your boarding pass at the check-in or the document check or at the boarding gate. And this provides us with some fixed reference point to timestamp each phase of the journey. But in between those milestones, we can go much deeper using a combination of AI video analytics, Bluetooth-based tracking, and these data fusion techniques. We can measure at every stage how long the customer or how long the passenger wait at check-in, at the security, at immigration, and even how they spend their discretionary time at the departure lounges, commercial zones. So for example, with the Bluetooth and AI fusion, we can detect how long a passenger stay in the retail store, as we mentioned just now. So even with the Bluetooth signals are randomized, our fusion approach can achieve 80% tracking accuracy. So all of this data is then aggregated to the flight level. So you can analyze, for instance, flight BE 1007 typically behave. So when they arrive, where they dwell, what they shop, how early or late they board. Now, this enables you not to only to monitor the experience and flow in real time, but also to optimize the commercial layouts and staffing per flight profile. So improving both the passenger satisfaction and airport revenue as well. So here, this shows a high level overview, but you can also drill down. So for example, you want to look specifically into flight 1012, then this dwell into flight 1012 at which date. For example, now where you're seeing here is this flight level, how many total passenger was for that flight, and what is the average dwell time where, and the engagement most visit zone is which one, and the engagement level in here, and whether or not they engage with the retail or the dining area, and all aggregated for this specific flight. So all the way from departure lounge and all the different zone before into the boarding gate. So you can see a majority of them, some go straight to the boarding gate, some go dining, then boarding gate, some go retail, some go both, then boarding gate. So all these are aggregated for a specific flight, and this allows you to drill down on there. With this level of detail, you can then categorize the behavioral profile of passengers of each flight. So you can categorize whether they are leisure travelers or they're business focused, if they're families, because we have demographic on there, and any last minute shoppers for souvenirs. So that insights become incredibly valuable for retailers and F&B operators. And also using the upcoming flight schedule from AODB, they can forecast footfall, adjust the staff and stock level, optimize their merchandising, and prepare their targeted offerings. So for example, like we say that this flight 1012, they consistently brings passengers who dine late but shop early, or so a restaurant may extend their prep timing while the retail can boost early presence. So ultimately, what you want to translate this is a higher sales conversion, better resource planning, and increased tenant satisfaction as well. So, and for airport operators, of course, then leads to stronger tenant rental yields, the higher per square meter returns, and data-driven planning for future retail expansion. Yeah. Now, so all being said, is very important. One of the most critical enablers in an airport-wide passenger flow monitoring is the open architecture. So not just as a technical principle, but as a strategic foundation for long-term value creation. So these systems generate highly valuable data. So this is not just counts as we demonstrated, but also operational performance metrics, retail behavior, flow intelligence, all this real power. But all this real power comes with when this data is combined with other silos like the AODB, the flight information display system, the baggage handling system, and the security system. So to create a cohesive digital twin of the airport. That is why our platform has been designed from the ground up with integration in mind. We support 6 key methods of data integration, allowing both the data import and export through the APIs, scheduled data pushes, SQL connectors, event-based webhooks, and more. So we also emphasize on the robust ETL handling, extract, transform, and load to ensure data integrity. So even when the data is delayed or missing or corrupted, we have built-in mechanism to detect all these anomalies. So attempt the automated recovery and issue alerts to maintain the continuity. So all of this is essential to enable a modular growth without a vendor login. So the airport operator should always own the ecosystem, and vendors should play interoperable, well-defined roles, not monopolize the architecture. So this level of openness gives you not only flexibility, but also resilience, allowing upgrades, replacements, and innovations to be layered without disruption. So we have covered this extensively in the previous webinar focused on integration strategies, and we'll be continuing that discussion in our upcoming sessions as well. So we'll share that webinar if you like on that. We talk more about the integration. So in our upcoming workshop, we're going to go deeper into how airports can continuously leverage the data to fine-tune their standard operating procedures, the SOP, and turn them into prescriptive and actionable workflows, so ensuring the consistent improvement in passenger experience. So it's not just a data, not just an insight, but actually using that to be able to ensure a consistent improvement on that. So to reduce queue times and to get more time and more engaging retail environment. So this isn't just about dashboard, it's about embedding a business rules engine that sits on top of the data. So defining thresholds, defining root causes, and accountability chains. So for example, when a queue breaches a waiting time, the system doesn't just alert, it will understand why it happened. So maybe when the queue built up, has all the lanes been occupied? So are the staffing level, was it due to staffing level? Was it due to lane closure? Or was it just a surge from a delayed flights? So it's not only just what and when it happened, and also the why embedded in there, so that when it then create issue and alert, it comes with a prescribed actions for the right stakeholder. So you can assign which stakeholder to receive these alerts on there. So then they can immediately take action to that and have a clear escalation path. And retrospectively, this allows for the root cause analysis with assigned accountability. Who was responsible? What action was taken? And how long was the reaction time? So this drives a culture of operational ownership and a closed feedback loop that scientifically guarantees a continuous improvement. So in a complex airport environments where scenarios shift by the minute, this type of real-time, rule-driven orchestration is the only sustainable way to scale service levels, to support the peak periods and to drive measurable passenger satisfaction. We'll be showcasing the practical use cases, the rule logic, and the performance improvement examples in the upcoming sessions, aligned with the RFQ discussion. Another upcoming workshop, we're going to talk about the validation methodology, because how is FootfallCam ensuring the ongoing accuracy and reliability of all the measured metrics, not just the in-out counting, but also live occupancy, waiting time, queuing line, zone level flow analytics. So all of this. So for a system to truly support an airport operation, the data must be trusted. Without that, the foundation collapses. So that's why accuracy validation is built into our architecture, with up to 12 automated methodologies cross-checking every aspect of the system. So from the AI-based visual counts to the Bluetooth BLE tracking and the first in, first out wait time models. So for example, the live occupancy count are validated using an end-to-end review process where a stitched together video of people entering, leaving a zone is manually human reviewed as a ground truth reference. And the occupancy block count displaying in the system is then compared to this visual ground truth. And the real-time view and movement path and queue formation are also cross-analyzed to validate the model behavior on there. So in this case of waiting time, we don't rely only on a single method. We actually apply and cross-validate first in, first out modeling in a confined spaces like the immigration zone, an entry exit journey time using AI tracking, Bluetooth re-identification, where is available, like for example on the retail side. So these three methods are plotted together on the same dashboard, allowing you to compare them daily. So when all these methods closely agree, then it confirms the accuracy. So if there's any discrepancy arises, the system will flag it for review. So creating a self-validating and self-healing data environment. So this multi-method real-time validation is a key differentiator of our system, and it ensures that operational decisions are always based on the most accurate and current data. So sustaining a long-term trust in the solution and reducing obviously the need for manual audits or intervention. Yeah, we will dive deeper into these validation methodologies with live examples and dashboard in the RFQ webinar. And also some other upcoming webinars on there, how do we integrate the AODB and the airport operation and data analytics on there. We welcome you to come to this other webinar. Okay, thank you.
Thank you, Dr. Melissa, on the insightful presentation. We have covered some great points today, and I'm sure our audience has a lot of questions. I can see in the chat we have already received some great questions. We'll now move to the Q&A section.
Okay, we have first question. How do you ensure accuracy of occupancy and waiting time in a high congestion scenario, like the immigration or security? So yes, so we employ redundant measurement methods, AI-based visual tracking, 3D stereo vision with the fish eye coverage, Bluetooth BLE, and the first in, first out modeling. So all these are validated against each other in real time, and a daily auto validation dashboards will highlight any drift or inconsistency with full video stitching available for audits. So this self-correcting architecture maintains the accuracy even during peak passenger surges. Next question, how do we integrate your data with our existing airport systems? You have AODB, RMS, BHS. We support 6 robust integration methods, API, secure FTP, DB sync, synchronization, event streaming, etc. So they are tailored for different system type. So all data follows the ETL best practices with the retry logic, delay tolerant queuing, and the alert mechanism for data loss or mismatch. So ensuring the data integrity and fault tolerance across the system. We do have, as I mentioned, we do have another webinar that we talk specifically on this. So we can share the webinar link to you. Another question, can your system distinguish between passengers? You have the meeters, greeters, and the airport staff. Yes, our multimodal AI models use behavior pattern. For example, lingering zone for the staff, the specific walk path for staff, and the attire, like wearing different uniform, and Bluetooth presence over time also as well to tag and learn staff versus non-staff. And we train this per airport. So it's a localized AI model for that. So, but over time, the system will learn and auto-classifies that and is with over 95% confidence. So staff zones are masked to prevent the distortion of passenger metrics. So this is very important for that. Next question, what's your approach for validating your data against ground truth? So we provide a validation snapshots, video-aided trace review, and per metric error breakdowns, so undercount versus overcount. So for key metrics like waiting time or occupancy, Human audits, video overlays, and automatic reconciliation dashboard confirm the alignment with the ground reality. So ensuring end-to-end confidence in reported figures. And we're going to talk more about this in the next webinar. The next question, how do you handle signal loss, occlusion, or camera NVR downtime? This is talking about the CCTV NVR downtime. So our system is built for a graceful degradation. So the edge AI units like the Pro 2, we buffer 72 hours of data. The Bluetooth data is queued with timestamp integrity. And in case of data dropout, the system applies a predictive interpolation and flags affected zones. So we have all these in place, and alerts are also triggered for any device anomaly. So audit logs will track the recovery events as well. Yeah. Next question, how do you account for overlapping zones such as the shops inside a departure lounges? So we define zone hierarchies and apply multi-layered counting logic, so allowing the analysis at both the retail unit and lounge level, avoiding the double counting. And the Bluetooth re-identification and movement paths determine the zone residency, enabling the accurate discretionary time mapping per retail or F&B zone. Yeah. The next question, how can this system help optimize tenant placement and retail merchandising? Now, by aggregating the per flight discretionary behavior, so this flight, what is the behavior? So we offer insights into where passengers dwell, how long they spend, what routes they take, so forth, segmented by the flight type. So the destination and passenger mix. So this enables a predictive modeling of retail opportunity per zone, guiding the tenant mix and staff planning based on real traffic. Is not just assumption. So based on real traffic and also with prediction as well with your AODB flight integration. The next question, how future-proof is this system, especially for airport expansion or layout reconfiguration? We follow a modular architecture, so each Pro 2 unit or Centroid and analytics node is self-contained and easily reassignable. So the Bluetooth beacons and camera feeds can be remapped within the AI, we can remap it. So the system can scale horizontally across terminals or floors, and any layout change is handled with a drag and drop reconfiguration in our mapping tool. We have another webinar that actually showcased that, especially in our shopping mall webinar. So we actually have a floor plan mapping tool. So it's very easy to use when you actually reposition or you change your floor plan and your facility layout. Next question, what makes the solution better than legacy systems like Zovis or standalone LiDAR? Now, unlike the mono sensor systems, we use technology fusion approach. So we have stereo vision, AI video, Bluetooth, BLE, and data triangulation. So this provides a greater accuracy in a complex open spaces, while also enabling the journey level analytics, not just a point counts. Yeah, we cover the whole journey level. So we are also more cost efficient with reusable IP camera infrastructure. With our Centroid, we can use your CCTV on there and an open architecture. For that, we can integrate with any of your other system. Let's do a last question. How do you support ongoing optimization, SOP improvement, and real-time responsiveness? We provide a real-time rule engine with alerting tied to your operation threshold. You need to set that up and we help you with that. For example, the queue time breach, abnormal inflow. So each of these alert is tagged with root cause attribution and the ownership accountability. Who is it? Is it the security department, or is it the border control immigration department? So combined with retrospective journey reports, this supports a continuous SOP refinement and staff performance review. So making optimization data-driven and measurable. So thank you.
Thank you, Dr. Melissa, for that insightful and informative presentation. We've covered some valuable topics today, and we truly appreciate your expertise. A big thank you as well to everyone who joined us for today's workshop. Thanks again for being part of today's session, and we look forward to seeing you at our next workshop.